Hi everyone, welcome back to my channel. In this video, we will learn what is capacitor and how does capacitor work. Capacitor is an electronic component that stores and releases electrical energy in the form of electric charge. Let's first look at the inside structure of capacitor for better understanding of its working. A capacitor typically consists of two conductive plates separated by an insulating material known as the dielectric. The conductive plates are usually made of metal, while the dielectric or insulating material such as ceramic or polyester helps preventing them from touching. Now we see, when we apply voltage to the capacitor, how the capacitor stores electrical energy. Before applying voltage, the capacitor plates are neutral. It means both plates have equal number of positive and negative charges on it. As we apply the voltage, the electrons on upper plates gets attracted by positive terminal, leaving behind positive charge on the plate. As the electrons get attracted by positive terminal of battery, the more positive charge is created on upper plate. As a result, the positive charges on this plate repel the positive charge away from bottom plate, which will then attracted by negative terminal of battery, leaving behind negative charges on bottom plate. When both plates are fully charged, they developed potential difference across each other. When the potential difference is equal to supply voltage, then no more current will flow, and capacitor is fully charged. The potential difference will generate electric field between two plates. This electric field is directly proportional to supply voltage, and inversely proportional to distance between two plates. At this stage, let's discuss how capacitor discharges. Remember, even when the voltage source is removed from charged capacitor, a capacitor can retain its electric field and hold its charge. Because the positive and negative charges on each of the plates attract each other but never reach each other due to dielectric. Let's say we connect a bulb across charged capacitor. Now what will happen? Bulb will provide closed path, which allows the charges to find another path to each other. As a result, they will leave the capacitor, and the energy stored in the capacitor could be used to briefly illuminate the bulb. Once the capacitor is fully discharged, no more current will flow and bulb will switch off. Let's understand the application of capacitor in an electric circuit. I will use water tank analogy of a capacitor with steady flow. Let's imagine the water coming out of a tap represents electric charge. If there is a fluctuation in water supply pressure, there will be no steady flow of water at the output. Now again imagine, we have a water tank connected to a water source, whose pressure is fluctuating. The tank represents a capacitor. The tank is designed to maintain a steady flow of water out of it, even if the pressure from the pump changes. This steady flow symbolizes how a capacitor can supply a consistent current to a circuit, regardless of fluctuations in voltage. If the water source experiences rapid fluctuations in pressure, like voltage spikes or drops, the tank absorbs these changes. It can momentarily hold excess water when pressure rises, and supply water steadily when pressure falls, ensuring that the downstream flow remains constant. This reflects how capacitors stabilize voltage levels in circuits, smoothing out fluctuations. At the end, I will explain that capacitor stores electric energy much less than a battery. For comparison, let's see an example. The energy stored in a capacitor is equal to half C/V square. A 1000 microfarad and 25 volts capacitor can stores 0.31 joules of energy. The energy of cell is calculated by charge into voltage. A 1.5 volts and 2 ampere hour small cell can store 3 joules of energy. I hope you clearly understand what is capacitor and how does capacitor work. For more interesting videos, stay tuned and don't forget to subscribe to our channel. Thanks for watching.